Go ahead and pause if you need more time. People who just joined us, they're starting to grade their evens. We already graded number 4. That was pulling out some important formulas from all the conversions. And then number 8 and number 14, we're graphing the points and then finding some other representations. Now, guys, number 14 is super boring because how many different ones could you have done? Yeah, infinitely many. So as long as your R is 0, whatever you put, you're totally good on for stuff like that.
Oh, we're just wondering, when are we going to get our test back?
Well, Tyler's still taking it today. Oh. But as soon as she's done, you guys can grab it tomorrow. No. And you guys need to take your quiz. So smart. But number 8 was a little bit more specific. Number 8, you couldn't just have the 1 or negative 1. You had to have angles that matched. So there were, for all of these, there are infinitely many. But this one's super easy. As long as R is 0, you're totally good on that one. But then you guys were converting points. Polar to rectangular and then rectangular to polar. You were allowed to use your calculator. You needed to, because 3/4, that's our tangent that we know. Square root of 3 over 3, 1 square root of 3. You would have had to actually take that one to your calculator. Some of you guys might have gone degrees instead of radians. They went radians. I gave you enough odds that I think you were able to see what they were doing as far as radians, not degrees. If you notice, from 26 to 52 to 72 to 98, I gave you guys mostly odds and homework, right? And that was very much on purpose. They wrote this one weird. I don't know why they wrote it in standard form. This is totally fine. You didn't have to rewrite it in standard form at the end. That's kind of weird. Apologies for that. You guys have any other evens past number 98? 98 was like an example we did in class. Oh, got it. Thank you. Oh, you need to go a little bit more? Right. No, it's okay. 98 was like that example that we did in class. It was a tricky one, so I did an example just like it, where the easiest thing was to take tangent of both sides. The easiest thing would have been to take tangent of both sides, and then there was a formula for tangent of theta equals y over x. So you can see some of that shown in the work. Are we good on 98 now? Okay. Let's get down to 108 and 122, and those are, I think, the end. Couple more seconds. .108 was like the messy one that we did in class with the double angle of cosine. So hopefully you guys were able to use that same formula we did in the example. And then remember, what is cosine? What is sine? What are you looking for? What picture are you looking for when doing these types of problems? The triangle. Good. So just a quick reminder of the triangle. For polar, all the different conversions, technically, we're just working with the triangle, with the theta and the r, the x and the y. That's how you can get that formula with x over r is cosine, and then solving for x, or y over r is sine, solving for y. Pythagorean theorem comes out of the triangle. Theta coming from tangent inverse. Or we could say tangent of theta is equal to y over x, and I think they use, that's just a variation. They use this one once or twice in homework as well. But once again, just coming out of the triangle. Getting back to homework, sorry. So that's how they got these ones to plug in, and they went ahead and were able to move the r over, and just like we did in class. That was the exact same problem. Oh my goodness, spoiled rotten. There's 122. I forgot. I did 108. Just kidding. And this one, there were a few different ways of doing it. One way is you could have made cosine x over r, moved the r over, and then plugged in. The other way is that you could have multiplied both sides by r, which is what they did, and then substitute. But Either way, they were able to move it to one side and use old school chapter 10A techniques of completing the square, and they figured out it was really just a circle with a center of 2, 0. All right, guys, I guess I don't. I have honors section open. Here we go. Now I have section 10.7 open. Is there something or anything else you guys, ooh, that's not right. There we go. I hit the wrong red side. Something, anything else you guys want to ask about 10.7 or homework problems you want to see? Jason.
Number 113.
Number 113. So, which one? 85?
45.
45. Let's start with 45, then 85, then 118. So number 45 was one of those point conversions. And he would be hard. Uh-oh. Come on, computer. You can do it. Maybe you can't do it. There you go. He would be hard without a calculator if you didn't know the unit circle, but with the unit circle, he's a little bit nicer now. My kind of fail-safe. So the first thing you should probably do with any point conversion is draw it first. So -3, +3. Oh no, -3, -3. There we go. So that's the quadrant that I want to get in for this point because I have an x and a y trying to get to an r and a theta. So I do have a couple different formulas. One formula I have is x squared plus y squared is equal to r squared. I'm just writing out the formula for you guys to see, which means I could plug in -3 squared plus -3 squared. To find r, the plus or minus square root, and 9 plus 9 is 18. 18 is 2 times 9, which would be 3√2 if I simplify my radical. And technically, remember, that could be plus or minus. I just need to get some sort of point that will land me in that quadrant. If I was doing theta, I would think of tangent inverse of y over x formula, which is tangent inverse of 1 square root of 3 over 3, 1 square root of 3, which happens at every pi over 4. So, you could use pi over 4 as your angle if you would like, but hold on, you guys know polar. If I use pi over 4, my point needs to go the opposite direction. So what can we do with r to make it land in the proper spot?
5 pi over 4.
Good. Well,
Add pi.
That's true. I'm going to put an or. You could have done 5 pi over 4 with what kind of radius? Positive or negative?
Positive.
Positive. 3√2. Or you could have done pi over 4 with what kind of radius?
Negative.
Aren't either of those great? Or you could have done positive √3/2 with a negative 3 pi over 4. Anyway, there are lots of different points that can get that one, but I would have used the formula tangent inverse of y over x, and x squared plus y squared is r squared. Now moving on to number, Salma, 85?
Yep.
That's a equation conversion, right? And he was weird because he had an A in him, which ironically isn't meant to make it tons harder, but it kind of does. A is just a constant, like C or B. A is representative of a number. So if A is representative of a number, we actually don't mind him being in there, but we got to get rid of the x's and the x squareds and the y squareds. But if you think about your formulas, wait a minute. What is x squared plus y squared?
R squared.
R squared.
So I can just take that and say r squared minus. And then 2a, isn't there a formula for x in terms of r and theta? What relates adjacent with hypotenuse?
Cosine.
Cosine. Does that make sense? So you could actually make your own formula, or some of you maybe studied that formula. But either way, we could plug in for the x with r cosine theta. And to be honest, I'm totally good if you just stop there. Because, well, hold on. Didn't we just see in the answer key? And I showed you guys on Friday also that sometimes it's just way too messy to get something alone. This one, it was way too messy to get y alone, and in polar, we normally get theta alone. No, sorry, r alone. But r is there, and r is there, and yeah, we're just gonna stop. Last one, Jason, 113.
Yeah.
Okay. Number 113 is on the other side. He's still an equation conversion, I believe. But, oh, hi, who are you? Go away. Okay. Here he is. Number 113 is going to require us to simplify a complex fraction because, well, we could go plugging in the square root of x squared plus y squared right now. But you guys see we have another problem?
Mm-hmm.
I think what I would do, Jason, is I would have gone and tackled that sign first. Just because, let me show you. In my head, just because I speak this language and done it for longer, I know that sign, I'm going to have to use both y and r to be sign. Opposite over hypotenuse, yeah. And so in my mind, I'm like, that's not my only r. I knew one was coming. And since one was coming, I kind of just waited. Because what I need to do right now is get rid of the r. Now, if you guys have gotten really good at my trick, you're going to multiply top and bottom by r. If you got really good at my trick, you're going to multiply top and bottom by r, because then you can go ahead and say 6r on top all over. 2r
minus 3y. Oopsie.
Now, do I have r's in lots of different places?
Yeah.
So then technically what I would probably do next, just in trying to get everything in one place, is I don't like the division. I would multiply it on the other side. I think you guys have kind of learned me enough to know I don't like division. So that would be 2r squared minus 3yr. Oops, not y squared. If I were to multiply this on the other side, multiply up. So 2r squared minus 3yr is equal to 6r. I know, it's kind of messy, right? Because then we have r's in so many different locations, right? The sad thing is, there's not really a gorgeous way of doing this. I'm going to go ahead and move this guy, adding him to the other side. They both have an r. Oh, wait a minute. Hold on. Can this turn out nicer than you thought? If I add this guy over, they both have an r. I pull the r out. What can I do to the r now? And actually what you end up with, I'm starting to run out of space because this doesn't scroll very well. I'm just going to come right up here. I now could go ahead and plug in my x squared plus y squared is equal to 3y plus 6. And there are different ways of simplifying that, Jason, but I would say. So, not gorgeous. Definitely way harder than anything you'll see on the quiz today. But
could you also have divided the 2r by 2 and just isolated r and be left out of the next step? Like, instead of that very last step where you turn it into the square root of x squared plus y squared.
oh, remember to go from polar to rectangular, all r's and betas have to be gone.
Oh,
Does that make
right.
sense?
Yeah.
So that's why I made that final substitution. But otherwise, like, you're right that it means the same thing. It just isn't in the proper form. All right, guys. I think we reviewed, not reviewed, I apologize. I think that we've done as many homework questions as we need to. Let's go back to our notes really quickly, because I am going to get you guys the quiz, the 10-question quiz pretty quick. Most of them are multiple choice, just a couple of them are graphing. Let's do a quick review. Sound good?
Yep.
Quick review. 2 sections, 10-6 and 10-7, right? You're allowed to have your graphing calculator out. When we did 10-6, what mode would you want to be in, say if I was to give you something from 10-6? If you saw t's, if you saw betas, remember, parametric equations come in par mode, and they come in pairs. There's always 2. So if I was to say something about your calculator, go in par mode. And if I was to do something in your calculator with r's and betas, you would now need to change to radians probably, because that's what we did in all homework. And then polar mode, right? So calculator, par mode, polar mode. If someone needs to grab their calculator, go out in the hallway really quickly and grab it. If you didn't bring it to class today. You're going to miss out on the review, but you'd rather have, I think, your calculator. If you had to do anything for parametric equations by hand, you're going to make a table and plug into your x and your y. But remember, when you graph parametric equations, don't forget to put the orientation. And the orientation is just as you go in order, it went from here to here to here to here. It's going this way. Just don't forget the orientation. If I say something about eliminating t, remember how we choose one equation, get t by itself, and then plug in? Right? The only time that gets weird is if you have some sort of trig, like, oh, don't worry, that's way harder than anything. Some sort of trig with cosines and sines, then the way to eliminate is cosine squared plus sine squared. So you would get cosine of 1, sine of 1. But some of you guys might even want to go to, no, I think that's harder than that. I was going to say that app menu where you went to conics, you could change that to par. Then in, section 10.7, how do we graph polar points again? Whenever we see a point, turn to the angle, and then if it's a positive r, go towards, and if it's a negative r, go opposite. Good. And then otherwise, I think the only thing that you might want is this page right here with the triangle, with x and y and r. If you needed to convert points or convert equations, these are the equations that you'd want to use. Now, quick reminder, in your calculator, if you are, because I'm allowing you to use your calculator, if you are allowed to use your calculator, where could you find, just in case there are some point conversions, where can you find how to convert points in your calculator if you needed to? Second, apps. Remember? So if you do second and then you do apps in the angle menu, there's a rectangular to polar r, rectangular to polar theta. So like the one that, Joe, you asked this one, -3, -3. As long as I'm in radian mode, which I am, I could go ahead and say, hey, that's my point, give me r, please. And I could go ahead and do the exact same, oh, no, I'd have to go do theta, do the other one. -3, -3. Now the problem is it wouldn't look as nice and pretty as in the book, because in the book we had 3 rad 2 instead of 4.24 because we did it by hand. And then this one's not going to look as pretty as it was in the book either, which I believe would be -3 pi over 4. Remember, there were lots of different variations. So it's not as pretty as what the book would have, but you guys could always, if you got decimals, couldn't you make them match with the multiple choice answers?
Yeah.
All right, I need desks totally cleared. Calculators are allowed to stay out. And then, yeah, please go ahead and grab a blank cover sheet. I don't think you need scratch paper. So I think you should be able just to use it as a cover sheet. You guys are going to have about 20 minutes. Yeah, scratch piece of paper, we'll just a blank sheet for a cover sheet. I really don't think you need extra. I really don't think you need extra. Alright, if you can show me work, try to show me work, because that way, if you can show me work, try to show me work, that way you get partial credit. Go ahead and stand up, wave your paper. As soon as your row is ready, I'll start passing. Once you start getting them, you can sit down. Once you start getting them, you can sit down. Let's just take the cover off your calculator because right now it's on the bed. We're going to start reviewing Monday. Monday is a Wednesday just for you. I'm doing what I can. For right now. See you next week.